Dart provides excellent support for async programming out of the box. In order to use these features, we'll need to import the built-in library of Dart Async. It provides a variety of different functions and data structures to perform async programming, but the two most important to know are futures and streams. In this video, we'll look at futures, which are very similar to promises if you have a JavaScript background. A future allows you to perform some kind of operation in the background, like possibly a read to a cloud database, which would normally be a very time-consuming operation. Without something like futures, the rest of your code would have to wait for that operation to resolve before executing. Under the hood, Dart implements something called an event loop that is also very similar to JavaScript that allows certain things to be queued up in the background and then handled later with a callback function. You don't really need to understand how an event loop works to get started with Dart and Flutter, but it is good to know that that's the underlying architecture that makes asynchronous code like this possible. A future is a one-time event. Something asynchronous happens, then you either handle it successfully or you catch an error because something went wrong. In either case, the future becomes resolved and you'll never have to worry about it again. Let's take a look at an example in the code. It's created by using the static method delayed on the future class for a duration of 5 seconds. Now, there are two things that can happen here. It can resolve successfully, in which case we can pass a function to then that will be executed after the 5 seconds is up. But there's also a chance that the future will throw an error, in which case we can append the catchError method and pass a function there to handle an error case. So the bottom line here is that we have two mutually exclusive functions. The one inside of then will happen when it's a success. The one inside of catchError happens when it's an error. Only one of the functions will be called per future. Now, one cool thing about Dart is that it supports a syntax called async await. It replaces then and catch to write code in a more synchronous looking way. When you define a function, you can add the async keyword after it, in which case it will tell Dart to automatically return a future. The cool thing about it, though, is that you can use the await keyword inside the function body. Await will pause the execution of the function until the promise in front of it resolves, and that eliminates the need to use then along with a callback function, which can result in cleaner code. When it comes to Flutter, there are dedicated widgets that can resolve a future directly in your UI, and that can be really useful when you need to fetch data from a third-party API, among many other things.